In today's video, I'm going to demonstrate how quick and easy it is to build a prototype focused around a theme of food delivery apps. Whether you are a Grubhub or DoorDash or Seamless or whatever user, you're familiar with all of the different algorithmically sorted and suggested lists that are presented to you, stars, distance, fees, timing. There are a number of different variables that are called out for you as a customer. I think that there is one glaring one missing here, and that is how well does a specific cuisine travel? I think a language model is particularly good at solving this problem because it involves understanding what most cuisines and typical food items that you might find on an app like this are actually made of, what is in them, how are they cooked, how are they prepared, something that could come from the base LLM behind the scenes as it's scanned and read the internet to have a general idea of what is in a poke bowl or corned beef sandwich. And I think it'd be great at analyzing your current cart as you are building an order to determine whether or not it is a good idea for you to order that thing based on what kind of food it is, how far away it is, and something that could help an app like a DoorDash or a Grubhub provide more consistent user experience by having a better idea of whether the food will still be as good as it could be when it arrives at the customer's door. So the first thing I want to do is just double check with GPT-4 if it can think through this kind of problem. So I'll ask a question like, if I order sushi for delivery, what's the furthest distance between me and the restaurant that you'd recommend? I just want to see if it can think through the different kind of aspects of what goes into food quality. So we've got city limits, we've got distance. It's calling out some things that are particularly sensitive to temperature changes. It's calling out a few different considerations and pros and cons at different distance levels. If we order further away, you might get more unique sushi options. Sure. Here we have temperature control, checking out packaging of the food, reputation. So it's doing some kind of general assessment and understanding around what might go into a decision to order food and how quality might kind of go down over the course of ordering it to be delivered. Now, if we pop over to Zero with Workbench, we can pretty easily replicate that interaction. If you haven't watched the video before this one, now might be a good time to pause and click on the link up in the corner there where I talk a little bit about the high-level structure of what goes on in the Workbench and how we've thought about breaking up those different roles and component parts of the kind of ecosystem around a piece of intelligence. Today, we're going to focus really just on a piece at the middle where we design the actual intelligence and the interaction with the language model. So I'm going to click on this button here and just hit Create Intelligence. Let's give this a name to start out with. We'll call it maybe Food Quality Calculator. I'm going to leave it with a chat and conversational interface to get started. You'll see what impact that has in just a second. This is going to belong to our tutorials organization, and we'll leave it so that anybody in this org can see and interact with it. Once this loads, now we're kind of in the home base within the Workbench for configuring and designing how the language model actually interacts with an end user, what instructions the language model is given in addition to the prompt or interaction the user might have with them, how that language model interacts with a knowledge set, the actual raw kind of model parameters, and we can begin to tinker with some things. First, let's just click this big button in the right to pop open the demo interface. I talked about this a little bit in that video I just mentioned where every single piece of intelligence within the Workbench automatically has a shareable live URL to a demo of the logic that anybody can interact with. You can share and send it around with your teams. Now, if we were to ask this the same question that we just asked GPT-4 in ChatGPT's interface about sushi ordering, we should get a similar answer. And that's because the component is also connecting to GPT-4, but just via its API. So if I click on this, we're getting a relatively similar assessment around things you might consider with regard to ordering sushi. Now, a chatbot flow for what I have in mind here is probably not right. If I'm thinking about the mode of ordering food in one of these food delivery apps, I doubt I want to have like a chat text conversation with a little piece of AI around whether or not I should be ordering sushi at this time. We really want a more automated embedded process that is leveraging a language model to make some assessments and inferences between what I'm ordering, how far I am from the restaurant, and anything else we should take into consideration, and use that to drive some kind of interface element that's just shown to me automatically. So let's start changing a couple of things. First, we'll go back over into the workbench, we'll come down to instructions, and make a new unique kind of custom instruction for this language model. And this say something like, you are a calculator for determining how food quality declines over the course of a potential delivery. Let's fix our little typos there. Base your decision on the estimated travel time for an order, specific menu items, and how it might be prepared or packaged by a restaurant. Now this message, we'll just call this instruction 1. This message is essentially going to be inserted into the context window for the language model just before the user's prompt. If we go back to our demo and refresh, and I say something like sushi, now we're going to get a answer that is already about delivery time and food quality with regard to sushi. Even though I, as the user, didn't say anything about food quality, I just said the word sushi, which would have gotten a really different reaction if we just typed sushi into ChatGPT. We've kind of primed the language model to focus on a specific topic, answer a specific question, and then we've given a kind of specific element of that question for it to respond to within regard to our instructions. So we've got basically the same answer that we've had before, and that's great. But again, chat is really not what we're looking for here. So let's go back over to our intelligence, and we'll come down to the demo interface, and let's change this from a conversational to a single response. When I go back up to the demo and refresh to reload this, now we have a kind of input and output view. On the left, we have our inputs, which we haven't configured any. So if I hit generate, what should happen is some kind of prompt saying, hey, you didn't give me a menu item to actually respond to. Those instructions we set up are still there behind the scenes saying, hey, you're gonna, judge food quality over time for a specific delivery, but we didn't actually provide any food quality to begin to work with. So now let's go do that. If we go back to our intelligence, that happens down in the inserted variables section. So I'm gonna create a new variable. We'll call this customer order. I'm gonna give it a kind of key or distinct identifier for how to refer to it within the instructions. We'll just do order in all caps, and we'll leave out any default. Down here, we've got some additional options for how this variable renders specifically within the demo interface in case you're trying to customize, create a little prototype for a particular audience. You want to kind of hold their hand into understanding how the variables are set up. For now, let's just leave this blank, and I'll hit save changes. If I come back up over here and refresh, now we've got a little box where I can enter in the customer's order. That's great, but if you noticed on this page, we have a little warning here. It says heads up, you still need to add this variable to your instructions. You can do this by typing $bracket order bracket into the content of the instruction. So I'm just gonna copy that, head over to our instructions, click on the one that we were writing before. We've got a similar error down here that there's, we created this variable, but we haven't actually used it yet anywhere. So let's do that. Say, here is the customer's order to analyze. And we'll paste in that kind of key with the $brackets and then the label that we gave it. And notice that error goes away, and I can hit save changes, go back to my demo, and I can just type sushi here. And now we should get some kind of similar output on the other side of it without needing to do the entire kind of chatbot flow. Great. This is still a very kind of ChatGPT style output. And again, this kind of single word menu item description of a meal probably also isn't accurate enough. So what we really want to build is something that can take the order within one of these apps, which is probably stored in kind of like a structured data packet of some kind, maybe an array or a list of each menu item that's being ordered, some kind of label for how long the order is going to take. We want to take that packet, give it to the language model, and have it analyze that in order to drive some kind of pop-up or aspect of the interface. So to start that, I'm going to actually pause and use ChatGPT to generate a fake data packet to work with. This is not really relevant to designing the intelligence itself. I just happen to be using ChatGPT as like a productivity tool here because I don't know how food delivery apps structure their data internally, and I don't want to take the time to try and invent that myself, so I'm just going to use ChatGPT to do it. So let's do something like generate a fake JSON packet representing what a food delivery app might store to keep track of an order, make the order for a sushi, make the order for a sushi restaurant, include some hot and some cold items, a delivery time measured in minutes. Let's actually make that estimated. And anything else that should be present. I don't know. There might be some other stuff that it comes up with that is useful. Again, if I was working at one of these companies, I would just use the order packet that is the real one, or like an example of how the actual data is structured. Since I don't know that, I'm just kind of taking this shortcut here. All right, now that that's done, we've got a delivery time of 30 minutes. That's great. We've got a driver that it added in, and we've got a list of some things: tempura shrimp, soup, dragon roll, salmon sashimi. Great. Let's just copy this, go back to our variables, and I'm just going to paste in the entire order there and analyze it and see what it does. Cool. We've got now a kind of more detailed readout. It wrote a little paragraph about each particular item. So the salmon and dragon roll should not impact their food quality. Miso and tempura shrimp might be more complex. Travel times are reasonable. It's hot food, might begin to lose their temperature after so much time. Take away some of their quality a bit. That's great, but that would be a lot to kind of like drive in a mobile app interface while you're busy trying to check out and pick your payment method and set a tip and whatnot. So let's do a couple things to try and focus the way it's responding. It's interpreting our data packet perfectly well. We can probably tweak the demo appearance of this variable here to make this box a little bit bigger. So let's adjust that, and then also tweak our instructions to, instead of generate paragraphs, maybe it should give us our data packet back with some specific fields added to it that kind of hold the analysis that then we could choose to display in the front end of our interface to an actual potential user. So let's go back over to the workbench. We'll come back down to variables. I'm going to go back in and edit the details of our order to change this to be a paragraph. That'll help. Now if I refresh this, we get just a little bit of a bigger box that I can paste something into. I think I might also just make this the default value so that when I reload this, it's going to come loaded with that sushi order. That helps if I'm trying to send this to a friend or a colleague that we're working on something. I can say it's kind of preloaded with this data packet, but it then also gives them the opportunity to edit it and play around with it if they want to bring their own data. Back in the instructions, let's maybe start to inform and instruct the language model to respond in a certain way. So let's do this. Respond in the same valid JSON format as the user's order. Say customer, so we're consistent. Customer's order. Adding a new field called max potential stars that describes the highest expected rating of each menu item that each menu item might receive based on how long the delivery is. If there's no expected impact in quality, give the item a max potential stars of 5. If the delivery is extremely long, then the max potential stars might decline all the way to 1. Let's do that. anytime we're kind of introducing a new concept in instructions, like this max potential stars thing, probably isn't something that I would have expected the language model to have a grasp of in the kind of base LLM, that kind of pre-training where it analyzes a huge amount of text. I'm making an assumption here, and we kind of tested it a little bit, that in that pre-training, it has a good enough understanding of how food is created and cooked and prepared to assess the name of a menu item and understand what might go into that. However, I'm not expecting it to know what max potential stars is. So since I have introduced the concept, let's maybe describe a few examples at each end of the extremes. I kind of gave a vague one here, but let's do something a little bit more specific and say, for example, pizza might travel well and take over, 45 minutes to drop from 5 stars to 4 stars. And let's just be really consistent to set it up for success and keep our terminology the same. While fast food might lose a potential star every 10 minutes, and a 45-minute delivery time would result in 1 max potential star for some items. Let's leave it like that. I kind of like the way that is structured. We'll get rid of that space. Hit save. We'll come back over to our demo. We can refresh it. Remember, we've got that sushi order now kind of saved in there for easy testing. I'm just going to click generate. And now we've got our data back. Look, we've got our order, but GPT did its GPT thing and it added a little bit of a description at the bottom. Still thinking I'm trying to have a conversation with it. Again, I'm using GPT-4, but in kind of an instruct way, if you're familiar with the difference between those models. I really just want this JSON packet and nothing else. So let's first fix this before we even assess how it handled the kind of max potential stars issue. Let's just reiterate kind of at the end of the training to kind of reinforce, respond in the same valid JSON as the full original customer order with no other descriptions. And then this is also a handy phrase for doing these kinds of things. Be as succinct as possible. We'll hit save and we'll run that again. Now you might notice that the load time on clicking this generate button is getting a little bit longer here. And that's because the API call that's being made between ZeroWidth and OpenAI isn't streaming each individual token in. It's just waiting for OpenAI to generate the entire response and then transmit it over to ZeroWidth, which is fine for this particular use case because I want to be able to have a data packet I can parse. And I'm going to wait until I have that entire data packet to parse it anyway. So now we have our results back. And we can see we have the original order nicely formatted now thanks to the demo interface. And I'll come down and click on items. We have our array of each item here. Salmon sashimi, max potential stars are 4. Dragon roll, max potential stars are 4. Miso soup, max potential stars of 3. So the soup might get worse quicker than those 2 sushi items. If we keep coming down, tempura shrimp, max potential stars of 3. And this kind of matches that open text description that we saw a little bit earlier, where it said, hey, the sushi is probably going to be fine if it's packaged up well, but the hot stuff is going to get cold over time. That's just obviously going to happen. So that's working pretty darn well. I might want to come down here into our order packet, and I can see we've got estimated delivery time of 30. Let's crank this up to 90 minutes. And regenerate it and see how much of an impact, tripling the order time will take on our potential stars. So we started with 4, 4, 3, and 3, and we'll see, does it drop to 2? Does it go up? Is it really confused? How well does the language model handle that shift in delivery time? And again, how well is it parsing that delivery time from the order without us really telling where it is in this order packet, or even how to, find the items array in the order packet either. All right, so it still thinks that the sushi is going to be fine. I might personally disagree after an hour and a half how the sushi will hold up, but it did drop the soup a bit further and the tempura shrimp a bit further. So that's working great. I think maybe for the opposite, let's move this down to 5 minutes or 2 minutes and see how well it handles that. Now, ideally, we should see probably 5 max potential stars for all the items because the delivery time is, almost nothing. I also am not giving it a unit on this delivery time. I didn't say 2 minutes, I just said 2. So there's a chance that maybe it's going to interpret this as 2 hours or with another unit of time, which then we might rethink how we're structuring the data we're actually giving the language model. So we're setting it up with enough context to accurately answer our question. But it seems like it did a decent job. Interesting enough, it's still dinged the tempura shrimp by a couple, but we've got the 5 stars on the salmon and 4 stars on the miso soup. Now, before we kind of wrap up this kind of part 1 of 2 videos focused on this, let's just get a completely different order. If we pop back over to ChatGPT to kind of generate food orders for us, let's say generate another, this time a mixture of food like burgers, fries, and chicken nuggets, etc. This way we can see if our structure and logic that we've, again, only been talking about sushi with it so far, how well it adapts when we shift that to something completely different. I would expect it would be to handle this just fine, but at the same time, we haven't given it anything specific about, burgers in here. We didn't talk about sushi either in our example, so it's already kind of bridging the gap between those 2 extremes that we've armed it with. But for the sake of testing, let's just try out another one. No ketchup on the burger. Extra napkins, please. All right. We'll copy this, go back to our demo, paste it, and run it. What did we actually order? We got a milkshake, chicken nuggets, crispy fries, classic burger. Okay. All right, let's see. We've got max potential stars of 4 on the burger, 3 on the fries. I agree with that. Fries get soggy pretty quick on a delivery. Chicken nuggets, kind of unaffected, and vanilla milkshake still doing well. So in the next video, we're going to do 2 additional things. We're going to add in a secondary variable here that describes the way the restaurant packages the food. So we're beginning to push the language model to not just understand an order and how the food might be prepared and make a guess, but synthesize that with how the restaurant is saying that the food is packaged. Are hot and cold ingredients separated? Do they use an insulated bag? Are things deconstructed so like wet ingredients stay wet and crispy things stay crispy? We'll add that as an extra input here, and then we'll also, in addition to generating that max potential stars, task the language model to use that rating to write some text that we could display in the actual app to the user that is highly contextual based on their order. So stay tuned for that. It's going to be a similar deep dive video kind of working on this particular example. And at the end, I think we'll have something pretty neat. So hit subscribe so that you don't miss that, and we will see you in the next one. Hey Siri, what should I order for dinner?
Here's what I found.
Right, I forgot.